Right guys, in this video we are going to discuss few more numericals on EMF equation. Let's see the questions. These are completely previous questions, previous examinations, competitive examination questions. An ideal transformer having primary number of turns, which is 100 number of turns, and the secondary number of turns are the 200. Secondary number of turns 200 with the mutual flux what they given phi m or mutual flux, this is with the function of time they given as 0.05 into t square minus 2t. This is the mutual flux with the function of time. Now the induced EMF of secondary in volts. What is induced EMF? Generally, the average induced EMF E is equals to minus N into d phi by dt. Here N is the number of turns. We need to consider the number of turns. So E is equals to the secondary number of turns 200 into differentiation of flux. What they given flux? 0.05 of t square minus 2t is our flux value. Yes or no guys? So now do this. Minus 200 multiplied with this is 5 by 100 and differentiation of t square is the 2t and differentiation of minus 2t is the minus 2. So what will be the answer? Can you tell me guys? Minus 10 into 2t minus 2. Minus 10 into 2t minus 2, which is nothing but minus 20 into t minus 1. Yes or no guys? Take a 2 common, it will be minus 20 into t minus 1 will be your answer. Okay, like a questions they will ask you in our competitive exams like a sets, E set, K set, D set and sub-engineer level of examinations and like a junior engineer in SSC JE, RRB JE. For all those examinations, like a questions are important for us. Let's see the next question. Let's see this question. In a transformer, if a transformer core has air gaps, so what is the meaning of this air gaps? Once have a look here. For example, this is my transformer core in which the low reluctance path is there, which is nothing but the flux moving in this. Suddenly in this magnetic core, if any air gaps takes place like this. So what will happen? When the air gaps takes place here, ultimately the air gap, air nothing but almost is a dia. This core is nothing but steel, steel nothing but almost a ferro. For ferro the permeability is maximum, for dia the permeability is minimum. Ultimately when the air gaps takes place here, its reluctance increases. When the reluctance increases, actually the flux will reduce, but we need to maintain constant. In order to maintain the constant, the transformer will draw the more current from the supply. So which is nothing but the I mu value will be increases. Of course there is no change in IW. I mu value will be increases. When the I mu increases, ultimately I naught increases. When the I naught increases, ultimately phi naught increases. When the power factor angle increases, ultimately the power factor will reduce. Power factor will reduce. So reluctance of the magnetic path reduces is a wrong answer. Hysteresis losses decreases is not relatable. Magnetizing current is greatly increases. Magnetizing current will increases greatly. This is the way of question, and of course you need to remember this word, its power factor reduces. When you draw the vector diagram, actually what you know, this is IW. For example, this is my I mu. The sum of IW and I mu is nothing but our I naught, and the angle between V and I naught is nothing but the phi naught. Actually this is the vector diagram under no load condition. Suddenly when the air gaps comes into the picture, its I mu value increases. Of course there is no change in IW. When the I mu increases, ultimately I naught increases. ultimately power factor angle increases, so the power factor will reduce. This is simply what about the second question. Let's go for third question. A 20-ton iron core inductor is connected to 100 volts 50 Hz source. The maximum flux density they given. The cross sectional area is, they are asking the cross sectional area. So what they given? The maximum flux density given 1 Weber per meter square, 1 Weber per meter square. Of course they given frequency also and voltage also. Voltage also they given, the number of turns also they given, and frequency also they given, frequency also they given. Simply we need to calculate E. E is equals to 4.44 into 5m into, B maximum into A into F into N, where V they given 100 volts. This is 444 by 100 into, and maximum flux density is a 1. Maximum flux density is a 1. Area we need to calculate. Frequency is the 50. Number of turns 20. So these two zeros, 5 2s are 10, 1 0 cancelled out. So A is equals to 10 out of 444. 10 out of 444. If you calculate this, how much you will get? 0.0225 will come. Yes or no? 0.0. 444 ones are, 444 twos are. And 122. And again 0, again twos are. And like that, if you calculated this value, you will get 0.0225 meter square or 0.225. Is it 22.5? 1, 2, 3, right? So 22.5 millimeter square we can say in terms of meter square, in terms of millimeter square, you can say the answer. But as per options, we can have directly. So this is your answer. Next, fourth question. A low voltage winding of a 400 volts, 230 volts, low voltage winding nothing but 230 volts side. Single phase 150 Hz transformer, 150 Hz transformer connected to 25 Hz, connected to 25 Hz. Then what will be the supply voltage? Indirectly, we need to maintain V by F constant. Of course, they are not mentioned here. So when V by F constant, the 230 by 150 should be equals to V by 25. V by 25, 25 ones are, 25 six are. 6 ones are, 6 twos are, 18. 6 threes are, 18. 18 nothing but almost 2 plus 3, 5. Nothing but 50. 6 eights are. 6 eights are. What they given? The low voltage side. So what is the answer? What is the answer? The voltage should be equals to around 38 volts like that. But there is no options. What they given? For example, this may be 200 volts, sir. If it is 200 volts, 200 by 150 is equals to V by 25. 25 ones are, 25 six are, even though there is no answer. So whatever there is a mistake in the options. But what you have to observe here, if the given question like this, we need to maintain V by F constant. When V by F constant, V2 by F2 should be equals to V1 by F1. What is V2? We need to calculate. What is F2? F2 is the 25 Hz. What is V1? V1 they given low voltage side, that's why 230. And frequency is a 150. For example, let's take if this is 50 Hz. Let's take if this is 50 Hz, 25 ones, 25 twos, 2 ones, 2 115. Yeah, is there. So here the mistake is that this is not 150 Hz, this is a 50 Hz. This is a 50 Hz, sir. So that is a mistake, question mistake. So by the V by F constant we can get. And here you need to observe that when the frequency reduced from 50 Hz to 25 Hz, nothing but the frequency halved. To get the V by F constant, the voltage also should be halved. If the voltage and frequency both are halved, then we can get the constant V by F, constant maximum flux density, constant magnetizing current, constant magnetizing characteristics. That is the thing here. Okay, this is simply what about the fourth question. And in the next question, let's see. Let's see, sir. This is actually very repeated question, sir. A single phase transformer has a turns ratio they given. Turns ratio nothing but 1 by K. 1 by K is a 1 by 2. Nothing but the transformation ratio is the 2. And is connected to a purely resistive load. This is a purely resistive load. As shown in figure. The magnetizing current they given. Magnetizing current is 1 ampere. And the secondary current is they given. Secondary current which is nothing but I2. I2 also 1 ampere. If the core loss and leakage reactances are neglected, core loss and leakage reactances both are neglected, yeah, the primary current will be, they are asking the primary current. When the core loss is neglected, core loss component also neglected, there is no concept of IW if the core loss neglected. If there is a IW, there will be some core losses. If there is no IW, there is no core losses. So, what is I naught? Can you tell me? I naught nothing but square root of IW square plus I mu square. IW is already 0 and square root cancelled. So, the no load current is exactly equal to magnetizing current, which is exactly equals to 1 ampere. My no load current is there. And can you tell me what is I2 dash plus I naught? I2 dash plus I naught is equal to I1, right? From the vector diagram. Yes or no, guys? For example, here V1, here V2, here some flux will be there. There is no IW, we have only I mu. We have only I mu, which is a 1 ampere. And when this is a purely resistive load, if this is a purely resistive load, the load current in phase, the load current in phase with voltage, which is 1 ampere again. Now I want I1. How we can calculate I1? I1 is nothing but I naught plus I2 dash. This is the I naught, this is the I mu. Where is my I2 dash? Exactly in opposite direction, you may have I2 dash. Sum of I2 dash and I naught is nothing but our I1. Now tell me, what is I2 dash? I2 dash formula, have you remembered? I2 dash is equals to K into I2. K is the 2, I2 is the 1. So, I2 dash is equals to 2 amperes. I2 dash is equals to 2 amperes and I mu is equal to 1 ampere. So, I1 is equals to square root of I2 dash square plus I2 dash square plus I naught square. That's it, because both are displaced by 90 degrees. Square root of I2 dash square plus I naught square. So, root 5 is your answer. Root 5 around 2.24 amperes. This is a previous GATE question and Genco Transco AE question, IES question. In many other competitive exams they asked, already repeatedly they are asking. So, what will be the answer here? Root 5 nothing but 2.24 amperes.